Welcome to the DIY Honda Garage channel. The diagnostic trouble code P1192 refers to a low voltage condition detected in the fuel tank pressure FTP sensor circuit of the Honda Civic models from 2011 to 2015. This sensor is essential as it measures the fuel tank's vapor pressure, ensuring the fuel system operates efficiently and minimizing emissions. Located within the fuel tank, the FTP sensor has critical wiring that connects it to the powertrain control module, PCM. When the voltage reading falls below approximately 0.23 volts, it indicates a malfunction in the electronic components or the associated wiring. It is vital to verify and record all relevant diagnostic data from the vehicle's onboard system before commencing troubleshooting. This information aids in providing context for any ongoing issues and can be instrumental in identifying both soft and hard faults in the system. The FTP sensor circuit low voltage error indicates an issue primarily related to the FTP sensor's ability to send accurate readings to the PCM. Generally, the FTP sensor is designed to monitor the fuel tank's vapor pressure, providing crucial data that helps control emissions and fuel efficiency. This sensor is typically found in the fuel tank, making it integral to the overall functioning of the vehicle's emissions system. Additionally, the FTP sensor's wiring connects directly to the PCM, conveying voltage signals necessary for system operation. When the FTP sensor experiences a low voltage condition, it often leads to various performance issues, ultimately triggering the DTC P1192. This potential failure can stem from wiring issues, sensor malfunctions, or problems within the PCM itself. Identifying possible causes for the DTC P1192 is pivotal for efficient troubleshooting. A malfunctioning FTP sensor is often the primary suspect, as it might not provide accurate readings, leading to the low voltage condition. Moreover, poor connections or loose terminals at either the FTP sensor or the PCM can result in intermittent failures, causing the voltage to drop below the required level. Wiring issues, particularly in the VCC6 line connecting the FTP sensor to the PCM, can also lead to voltage drops or disconnections, which must be thoroughly investigated. Lastly, outdated or erroneous PCM software might misinterpret sensor signals, contributing to false low-voltage indications. Each of these factors needs a meticulous check to ensure a comprehensive resolution. When the DTC P1192 is triggered, several symptoms may become apparent. Drivers often report engine performance issues such as reduced power or poor acceleration, which may stem from the PCM receiving incorrect data about fuel vapors. The check engine light, CEL, also known as the malfunction indicator light, MIL, illuminates on the dashboard as a direct result of fault detection in the FTP circuit. Additionally, there may be noticeable fuel system inefficiencies, which can lead to decreased fuel economy or stalling under specific circumstances. Emissions may also be affected since the low voltage in the FTP sensor directly influences vapor pressure readings, potentially causing increased emissions and violating environmental regulations. Recognizing these symptoms is crucial for diagnosing and addressing the underlying issue effectively. In the first step of troubleshooting DTC P1192, start by turning the ignition switch to the on position, marked as Step 2. Once this is done, it's essential to check the voltage reading of the FTP sensor using the Honda Diagnostic System, HDS. This diagnostic tool provides a data list that allows access to real-time sensor readings. You need to determine if the voltage is approximately 0.23 volts or lower. If this reading meets the criteria, you confirm that the failure has duplicated, allowing you to proceed to the next troubleshooting step. However, if the voltage is above this threshold, it suggests an intermittent issue, indicating that the system appears to operate correctly at this moment. In such cases, inspect for poor connections or loose terminals, specifically at the FTP sensor and the PCM, which can sometimes lead to fluctuating readings. For the second step in troubleshooting the DTC P1192, begin by turning the ignition switch to the lock position, denoting it as position 0. Following this, disconnect the FTP sensor by accessing its 3P connector, a vital step in isolating potential faults. After disconnection, turn the ignition switch back to the on position again. Utilize the HDS to check the voltage reading of the FTP sensor once more. If the voltage is about 0.23 volts or lower, it confirms that the issue lies further downstream, prompting you to proceed to step 5. However, if the reading is above this level, it indicates a functioning sensor and leads you to step 3, where further explorations into the FTP sensor and associated components are warranted. Step 3 involves measuring the voltage between designated test points while ensuring that the ignition switch is in the on position, indicated as 2. First, with the FTP sensor still disconnected, measure the voltage between test points 1 and 2. Test point 1 corresponds to the FTP sensor's number 1 pin, typically colored blue, while test point 2 corresponds to the number 2 pin, typically black. You need to check if the voltage approximates 5.0 volts, which is the expected reading for proper sensor operation. A yes response indicates a functioning circuit, prompting you to replace the FTP sensor and subsequently carry out the repair verification process. Conversely, a no reading leads to step 4, to investigate further, as it suggests an issue lies within the wiring circuit or the sensor itself. In step 4 of troubleshooting the DTC P1192, begin by turning the ignition switch to the lock position marked as 0. Following this, initiate the SCS line jumping procedure with the HDS to isolate the circuit for further evaluation. Disconnect the relevant connectors, including the FTP sensor 3P connector, the VCC6 wire, and the PCM connector A from the system. After these disconnections, utilize jumper wires to interconnect the FTP sensor's first pin to the body ground for testing. Check for continuity between the specified test points to confirm if the VCC6 wire is intact. If continuity is a match, this indicates that the wiring is functional, prompting you to consider updating the PCM software or substituting it with a known good unit. If not, an open circuit in the VCC6 wiring configuration must be repaired before proceeding to repair verification. Step 5 focuses on identifying any potential short circuits within the PF0 sensor, PF0 wire associated with the FTP sensor. To begin, turn the ignition switch to the lock position, 0, before proceeding to jump the SCS line using the HDS as a preliminary measure. Disconnect connectors from the FTP sensor, VCC6, and the PCM connector A to isolate each component effectively. Subsequently, you will measure continuity between the designated test points. One test point should connect to the fuel rail pressure sensor pin, and the other should connect to ground. Confirm continuity. If present, it suggests a short exists within the PF0 wire, necessitating appropriate repair actions. If continuity is absent, indicating the wire is intact, consider updating the PCM software as a means to address any discrepancies before completing the troubleshooting process. After completing all recommended repairs, it is essential to perform a thorough final repair verification. Begin this process by turning the ignition to the lock position, marked as 0. and then meticulously reconnect all previously disconnected connectors, ensuring secure and proper connections throughout. Once all components are in place, turn the ignition switch to the on position, labeled as 2, to power the systems back up. Use the HDS to reset the powertrain control module, PCM, which clears all error codes from the system and allows for fresh readings. Perform the PCM idle learn procedure, designed to calibrate the PCM following repairs. Finally, check the HDS for any pending or confirmed DTCs to ensure DTC P1192 no longer appears, indicating a resolution to the initial issue. If DTC P1192 is still present, investigate further for connection issues or consider the need to substitute the PCM if it has been updated. Establishing a preventive maintenance routine is vital to avoiding issues like DTC P1192 in the future. Start by conducting regular inspections of the connections at both the FTP sensor and the PCM to ensure they remain secure and free of corrosion or dirt buildup that might lead to weak signals. It's also wise to be proactive regarding software updates for the PCM, as updates can rectify previous issues that may affect sensor readings. Additionally, maintaining the integrity of the wiring that connects the FTP sensor to the PCM is crucial. Check for wear and tear, fraying, or damage, which could cause faults in the communication between components. Keeping abreast of these maintenance tasks minimizes the risk of conditions leading to DTC P1192 and enhances the overall performance of the vehicle's fuel management system. In conclusion, DTC P1192 indicates a fault in the FTP sensor circuit, primarily associated with low voltage readings. This issue can stem from a faulty sensor, wiring issues, or software malfunctions within the PCM. The troubleshooting process emphasizes a systematic approach, problem verification, voltage measurements, and thorough inspections of connectors and circuits. After identifying the fault, appropriate repairs or replacements should be made to resolve the issue. Moreover, preventive maintenance is essential to ensure the longevity of the system and to minimize future occurrences of similar DTCs. Understanding the role of each component and their interconnections aids in achieving effective diagnostics and repairs, leading to a well-functioning vehicle. Please like and subscribe to the channel. See you next time.